Let's start from the very top. Expanding and factorizing are inverse operations. We know that. If it's safe to say that expanding is the opposite of factorizing.
Yeah.
It's very safe to say that, yeah. And they are used to manipulate algebraic expressions. Manipulate could mean to simplify, and then to, of course, solve those equations if there's an equal sign. So take note of that. Manipulate algebraic expressions. Algebraic expression means that that means those ones don't have an equal sign. Once you put an equal sign in an expression, it immediately becomes what? An equation. Okay, did you get that?
Yes.
All right. So let's keep going. It says a two-step equation typically refers to solving for a variable. Example, what we have in the bracket. So that example that's in the bracket, does it look familiar? 2x plus 5 equals 11.
Yeah.
Okay. All right. So if you are to solve that, then if we are solving that's part of, or it falls under um, what we call two-step equations. Expanding and factorizing are the core techniques used when those equations involve brackets or squared terms. Okay, so let's look at an example of expanding. Um, of course, I'm going to probably look for more questions so that we can have more practice with this. Now, can you see the example here where it says 3x, 3 into bracket, x plus 5, close bracket? Can you see that example?
Which one?
3 times bracket, or 3 brackets, x plus 5, close bracket. The example, the one that says single bracket.
Oh yeah.
Okay,
I can
single
yeah.
bracket. Yeah, multiply the outside term by each term inside. This one is a simple skill, and I'm sure you already know how to do it. So 3 will multiply x to give us
Mm.
3x, and 3 will multiply plus 5. Now take note, I said 3 will multiply plus 5. That means I'm taking note of the sign, okay? And because 3 is also a positive number, it multiplies another positive number. The answer will still be what? A positive number. So you have 3x plus 15 as the final answer for that. Now, excuse me. Now let's look at a case where we have double brackets. Let's see a case where you have double brackets. Now with the double brackets, um, there's a way I usually do this. So I'm going to have to leave this. Let me see if I can reshare my screen. So just take note of the question: x plus 2, x plus 3. Um, that's the question. I hope you can still see my screen.
Yeah.
Okay, good. All right, so I've moved into Notepad. Let's let's do something with Notepad. Can you see the Notepad?
Yes.
Paint, sorry, not Notepad. It's Paint I meant. Okay, so let's leave it at black, and then let's work on this. So x plus 2 is in one bracket, and I think x plus 3 was in the second one, right?
Mm.
Okay, so I want you to see how there's a very, I don't know if your teacher showed you with this method, but there's a very simple method that helps us with multiplication like this. So here goes. All right, so let me change the color now so you can see the steps going. So the first thing we're going to do is to start with the first one in the first bracket, which in this case is x, the x on the left-hand side, not the x plus 3, but the x plus 2, the x in x plus 2. So we're going to go this way. Watch. It will take on x first,
Mm-hmm.
Then take on plus 3 next, and then it's done. Why? Because there's nothing else that comes after the plus 3. Then 2, 2's own, let me do 2's own on top. 2 will take on x, and 2 will also take on plus 3. So take note of the order. Let's now do it in the order which I specified, which is that what? This is step 1. This is step 2. This other one is step 3. And this last one is step 4. So let's take note of it. So for step 1, x times x is what? X squared, isn't it?
Mm-hmm.
Now look at step 2. Step 2 is x times plus 3. Again, I'm saying it as plus 3 because of what? The sign. And x times plus 3 is going to be what? Plus 3x. Okay, take note. We don't, I know, I don't know if you had that question like me. There was a time that, still in my baby stages of algebra, I was like, why is it that we cannot have the letter written in front of the number? Well, why why is mathematically um, the same thing, that whether the x came before the 3 or the 3 came before the x? I think it's more agreed among mathematicians that the number should always come before the letter so that it's clearer to read, and it's easier to read. So x times 3 is what? 3x. Now, take note of the next sign I'm putting in front, which is the plus sign. How do I know it's a plus? Because I have plus 2 and what? X. So plus 2 times x is going to be what? Plus 2x. So two positive numbers multiply themselves, plus 2x. And then finally, plus 2 times plus 3 is what? Plus 6. Okay, so let's push it further. You are now left with x squared plus, now because the guys in the middle are the same term, what do you think is going to be?
Pardon?
The two terms in the middle, these ones, the 3x and the plus 2x, what will be their sum?
5x.
Exactly, 5x. So, and take note, they were the only like terms in this whole thing. Okay, so that's 5x. And then what do we have next? Plus what? 6. And we're done. We're done expanding it. That is the full expansion of this. So, all right. So I had to do it that way so that you would see the order. I'm not too sure about, I like the way they did it too, but I think I like it when I use those arrows. Those arrows help you to see clearly what's happening. Okay. So do you have any questions for expanding now? We'll do more practice so that you can see um, more examples. But do you have any questions so far?
No.
Okay. So what we just did now was expanding. Let's look at one more case, which is a case of factorizing, which is like the reverse of expanding. Okay. So let's take a very simple one. We'll come. In fact, maybe we should even look for fun. Let's just reverse the one that we have done. The first one that we did there was what? uh, 3x, 3 into bracket x plus 5, which gave us 3x plus 15. So let us go the reverse method. Let's factorize that guy. 3x plus 15. Let's see what we'll get. So the question in this case is what? Factorize. So if you notice, factorize doesn't usually have brackets. Now let me say
Mm.
something here. I didn't say you may not see a question. You will never see a question that will tell you to factorize, and then uh, there's 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 a bracket in it. You may see one, but guess what? The brackets are not well done. In other words, you can still do an expansion and then do a proper factorization. Don't worry, I'll see if I can find an example, but if not, we'll just be okay with the fact that one is the opposite of the other. All right, so here we go. We're to factorize 3x plus 15. Now, if you looked at the method in that on that Google page, it says we should find the highest common factor, HCF, the highest common factor between 3x and 15. Also taking note of the sign. So what would you say is the highest common factor between 3x and 15?
3.
Thank you very much. That's 3. So that's going to give me 3 into what? You can now put your
Bracket.
bracket. Yes. And when you factorize 3 out of 3x, which is like a division operation, you are left with x, isn't it?
Mm-hmm.
And then because it's a plus sign, plus 3 being factorized from plus 15, it's like saying 15 divided by 3, which is what? 5. And we're back where we started. Okay. So you can see expansion will take us from here to here, while factorization will take us from here to here. Okay. So the one on the left is factorization. The one on the left is expansion. Okay. So let's do the same thing for this second guy. Now, this second one, right, where we saw clearly two brackets, giving us x squared plus 5x plus 6. There's one interesting method. I don't know if I've taught you that method, but I have a feeling that we may have come across it somewhere, somehow. But let's revisit it so that it will stick with you for life. So this is the interesting method I'm talking about. It involves asking yourself two very crucial questions, or should I say three crucial questions. The first question you ask yourself is, the coefficient of the variable that has squared, because that's the determining variable in this case, that tells us that this is a quadratic equation. The coefficient should be 1. I hope you know when you don't have a number in front of a letter in algebra, that 1
Yes,
is
1.
assumed to be there. Exactly, good. So, because of that, first question you ask yourself, what number do you have here? If it's 1, then you can now go ahead and ask yourself these questions. What two numbers, when I multiply them, will give me plus 6? Take note, this last one answers multiplication question. Let me write it there. X. Now this X looks like the other X I just wrote. If you notice, it looks straight and not curvy kind of X. That's why it's multiplication. Then when you add those two numbers again, you have what? Plus 5. So the middle one answers the question of what? Addition. Let me take it again. What two numbers are there such that when you multiply them, you get 6 plus 6, and when you add them, you have plus 5. Now, what numbers come to your mind? In fact, you can even focus on the multiplication. The addition will figure itself out. So what numbers can give you 6 when you multiply them from your times table?
3 and 2.
3 and 2. Okay, now you also know that 6 and 1 would
6 on,
also,
yeah.
yeah, 6 and 1 But the problem is that 6 and 1, when you add 6 and 1 together, you will not get 5. Nothing will make you get 5. I hope you agree with me.
Mm-hmm.
All right. And now somebody may be saying, but what if there was a minus on the 1? So that means 6 plus minus 1. Yeah, that sounds like 5, isn't it? 6 plus minus 1 is 5. But check the flip side. When you multiply 6 and minus 1, what do you get? Is it not minus 6?
Mm-hmm.
Meanwhile, our question wasn't what two numbers will we multiply that will give us minus 6, and when we add them will give us plus 5. No, our question was what two numbers will you multiply that will give us plus 6, and when you add them will also give us plus 5. And the only two that meet that criteria are what? 2 and what? 3, or if you like, plus 2 and plus 3. So just, based on this x squared, when you see an x squared, then you are very, very sure that there must be two brackets that did what? Contain x somewhere inside them. So you just put those two brackets first. That's what that's that my method says. Just put the 2x first. Whatever will show up in the remaining ones will come up, like that. Then the two numbers that met your conditions, you just put them gently like that, with their signs. Okay? So because this one was plus 2, both of them were positive, plus 2 and plus 3. Just write it like that. And that's it. That's it. Now, I know you might be thinking, does that look like we've skipped some steps? Okay, that's fine. If you want to put in all the steps, look at what you do. If you want to put in all the steps, look at what you do. You are going to say x squared. You replace that middle guy with the two numbers that you discovered. So you are going to replace 5x. And 5x is obtained by saying 3x plus what? 2x, isn't it?
Mm.
So first replace the middle term with the two terms that you found. Of course, don't forget to append the x to them, because that's the only way you will have 5x. Then don't forget to put your plus 6 so that the equation is the expression is complete. What now do is to do what? Factorize by what grouping. So guess what we're going to do? We're going to group the first two together. These two like this, we'll group them. And then these two like this, we'll group them. Okay, now what's the HCF of x squared and 3x?
Is it X?
Yes, I agree with you. It's x. So let's go for x. I'll put my x outside the bracket. And when I factorize x out of x squared, I'll be left with x. And of course, when I factorize x out of 3x, which, like I said, is a division, 3x divided by x is what? 3. So there we go. Can you see that?
Mm-hmm.
Now, but we're not done. You now need to go to the next one. The next one you have is plus 2x and plus 6. What is the highest common factor here?
Is it 2?
Yes, it's 2. Very much 2. And guess what? It's a positive 2, because, that's the only way this thing can work. Now, let me give you a secret here. We always look at the first bracket and make sure that the second bracket looks like it. So this one, of course, and this is how you will know that you're correct, when the second bracket looks exactly like it, because when you factorize 2 from 2x, you are left with x. And when you factorize 2 from 6, which is like a division operation, 6 divided by 2 is what? 3. Did you see that you have x plus 3 here and x
Mm.
plus 3 here? Good. Now, guess what we're going to do? We'll factorize the x plus 3 out. Why? Because they are common. Now, let me tell you something. Anytime you see a plus sign or a minus sign, especially between things that are multiplying themselves, check very well. There might be an opportunity to factorize there. There might be a very good opportunity to factorize. Now, let us look if what I just said now applies here. Can you see that here, this first one, I have x times bracket x plus 3. Can you see? That's a multiplication relationship, isn't it?
Mm-hmm.
Now, can you also see that on the other side of that plus sign, this middle plus sign, this one that I just put an arrow for, not the other one. So there on the right hand side, there's another multiplication relationship where I have 2 times bracket x plus 3. So if that is the case, I can factorize whatever is common. And in this case, what is common? X plus 3. So I'll bring it out. And of course, that means that a bracket will be left showing what is left, what is remaining after I've factorized it. So when I factorize x plus 3, of course, I'll be left with x because, like I said, it's like a division operation, isn't it? Imagine
Mm-hmm.
dividing x times x plus 3 over x plus 3. The x plus 3 will cancel itself, leaving you with x. Am I right?
Mm-hmm.
Same thing with 2 times x plus 3. The x plus 3 will cancel itself, leaving you with 2. So we have arrived at where we got to again. So that this is it. Okay. This is the solution. Okay. So um did you guys do difference of two squares?
Uh, what do you mean?
The difference of two squares, two square numbers, the difference of two square numbers. Did you guys do anything like that when talking about factorization and expansion?
I'm not sure. I can't remember what it is.
Okay, okay, don't worry. If you are not sure, even if they didn't teach you in class, let me just quickly introduce it to you. But if they taught you in class, then just let me know after I'm done. Difference, they call it difference of two squares. Okay, because they look special. All right, and you very soon see the reason for what I just said. Difference of two squares. Two squares. Okay, here we go. So how does it look? Just if you look at the name gives itself away. Two squares, difference of two squares. That means difference is the answer of subtraction, isn't it? Squares is when something multiplies itself. So I can give you an example. Difference of two squares. And usually the questions around it are to factorize it or expand. So look at how this one looks. X squared minus 9. Okay. Now they give you this kind of expression. I know the first thing that will come to your mind is, wait a minute. This looks like a quadratic equation, but it's not complete, isn't it? It looks
Mm-hmm.
like it's missing the middle part, right?
Yeah.
Good. Now I want to tell you something that it's very, very complete. It is what we call, in this case, the actual difference between two squares. Now, what are the two squares? Let's see what those two squares are. I'm sure you've already seen it. X squared and 3 squared, isn't it?
Mm-hmm.
So let's write it like that. Okay, so next, this simple method of factorizing says you should take one of each of them. and put inside the first bracket. Okay?
Mm.
Then take one of the second one. Of course, put the minus there. Take one of the second one, which is in this case 3, and write it in the same bracket. What next? You are now done with the first bracket. The rule also says open another bracket. Take one of each one. But instead of minus now, what are you going to put there? Plus, which is the opposite of minus. And can you see that it has been fully factorized?
Mm.
Now, let me show you something. If you were to expand it, let's see how it's going to look. Let's do some practice with expansion. So, again, I'll change to, okay, different color. So, expansion. Remember, expansion, when you have two brackets, x will take on that first x. X will take on plus 3. So this is step 1. This is step 2. Okay. Then now take note of this one. There's a minus sign in front of the 3. So I'm going to put, do you understand?
Mm-hmm.
And say minus 3 times x. And then minus 3 times plus 3. So now let's see how it plays out. The first one is what? X times x, which is what? X squared. Everybody's pretty sure about that. X squared. Then step 2 is x times 3. Okay, so are you still following me?
Yeah. Yeah.
All right. Okay, sorry, um I took a break there. Okay, so let's continue. So x times x is x squared. X
Mm.
times plus 3 is plus 3x. That's the second step. Plus 3x. Okay, now we're done with x. Let's go to minus 3. Minus 3 will now do its job and multiply by x, which will be what? Minus 3x. And then finally, minus 3 will multiply plus 3, which will be what? Minus 9. Because negative times positive is negative, right?
Mm.
Okay. So take a look at that. What do you think will happen to the guys in the middle? Hello, Mason. Can you see what I did back there?
Yeah.
So what will happen to the guys in the middle? The plus 3x minus 3x.
Oh, wait, will the three axes take away from each other?
Yes, that's what will happen. 3x minus 3x is 0. So you are finally left with x squared minus 9. So can you see
Mm-hmm.
when we said factorization is the opposite of expansion?
Mm.
It actually agrees. Okay, so do you have any questions? This is the thing about difference of two squares. There's no big deal about it. It's very straightforward. Do you have any questions?
No, no, no.
Okay, good. So I want you to do some in line with this. Have you guys done, okay, do you remember doing this in class at all? The difference of two squares.
No, not really, but I guess it was good to learn it. I don't think so.
Okay, all right, all right. Okay, that's good. Okay, okay, so maybe, okay, don't worry. Let's just focus on what you have for your test, because my battery seems to be to be going. Okay, maybe I should just quickly give you one more example. So let's say we have 16 t squared. Always remember, it's a difference of two squares. So the minus sign must be between the two squares. Minus 25 w squared x raised to power 4. Now, I know this thing you might be wondering, can we have an expression like this? Yes, it's possible. But the only thing is just for you to apply the rules. Remember, take one, find the square root of each of them and take one of each. The square root of 16t squared will be 4t. Do you agree with me?
Mm-hmm.
The square root of 25w squared x raised to the power of 4 is 5w x squared. Do you agree with that?
Pardon?
5wx squared. Do you agree with that?
That agree with that. That what?
That is the square root of 25w squared x raised to the power of 4.
Yes.
Now, why I brought this example up was so that you can see that square root is not only when you have squared on top. It can be any even number, and they're asking you for the square root of that even number. The important thing is to know how to break things down. Okay, so if square root of x raised to the power of 4 is x raised to the power of 2, then square root of something like x raised to the power of 6 is definitely what? X raised to the power of 3. Does it make sense?
Mm.
Okay, so I just thought I should just say that so that we are on the same page. Okay, so of course, don't forget it's not done. You close the first bracket and then open the second bracket and do the same thing. But the second bracket will contain what? Plus. Don't forget, the second bracket will contain exactly the same numbers involved. But instead of minus, you have what? Plus in between. 5w x squared. Okay, all right. Did you see that?
Mm.
Excellent. So let's jump into indices before the laptop goes on a holiday. So
Mm.
indices. I always, I wish we had more time. I would have done a proper introduction to indices. Please, just remember this, okay?
Okay.
Indices is the plural of the word index. Okay. Well,
Mm.
mathematics. Yes. Index. So I know in English you might say indexes, but well, in English is you can say indexes, but in mathematics, instead of plural of index being indexes, it's actually what? Indices. And an index is equal to the word order. Okay. And I'm sure you're already beginning to think about where you've seen the word order. If you remember your board mass, the
Mm-hmm.
O in board mass is actually for order. Okay. That's, in other words, powers. And then another word for order is, I'm sure you should have taken it out of my lips or read it from, or heard it as I said it. Powers. So now you know what's happening. Okay. Index, order, power. All of them are the same thing. You can call them synonyms of the highest order, of the highest degree, rather. Okay. So why did I do this? So that anytime you see any of them, you can relate. So let's quickly jump into the laws. The first law, I'm going to use X. The first law says that when you have two numbers, or two uh, entities, and the bases are the same, please take note of the condition. The bases must
Mm.
be the same. Let me show you what I mean by the base. The base is the number that is down. Okay, the power is the number that is on top. So for instance, now in this thing that I just wrote now, X is my base, A is my power, my index, or my order. Did you get that?
Mm.
Okay. And it says that when two numbers are multiplying, you know what? Let me not use X. Pardon me. Let me use another letter. So that's because sometimes the what do you call that thing? It gets mixed up sometimes. The X now starts looking like multiplication. Okay. All right. So I'm using the letter D. So when you have D raised to the power of A times D raised to the power of B, that means the D is what they have in common, isn't it?
Mm.
Whether the powers are the same or not, we don't care. Important thing is that the bases are the same, please. That's the important thing. Now, if the bases are the same, the laws of indices says that when you have multiplication, that you are free to keep one of the bases and add the powers together. Okay, I'm sure that one is
Mm.
very familiar to you. So applying it should not be hard. Now, if multiplication leads to addition for the powers, don't you think division should lead to subtraction for the powers? Did
Yeah.
you did, did you get my reasoning back there? If let me say
Mhm.
it again, so maybe you to take some time to
Wait.
sink in.
Okay.
If
Yeah.
division, if multiplication leads to addition of the powers, don't you think division will lead to subtraction of the powers?
Yes. Yes.
Excellent. So let's flow on to the next rule, and that rule is for what? Division. It says that when you have something like this, and I'm going to write it in different ways so that we are on the same page, and you have D raised to the power of A divided by D raised to the power of B, and which can also be written as D raised to the power of A divided by, that means that one is the numerator, D raised to the power of B, that it is by law of indices given by, take one of the bases, which is what? D, and then write the power of the one in the numerator. So that means A must come first. Did you get that?
Mm.
Minus B, the power of the one in the denominator. It says that's the answer. It's as simple as that. So please don't forget the power of the one in the numerator minus the power of the one in the denominator. Okay. So I had to write it like this so that anyone the question comes with, well, we know what to do. Okay. So beyond these two laws, did you guys look at any other laws in indices? Because now let me show you another law. If it looks familiar, please let me know. Then I'll know that we did three laws. this law is interesting because it says d raised to the power of a. So you've already raised d to a particular power. Then you now raise everything to another power called what? B, that it is equal to what? D raised to the power of a times b. That you are free to multiply the powers. That's what that law says. Did you guys look at this particular law I just wrote down?
Mm.
Okay, so it looks familiar, right?
Mm-hmm.
Excellent. Okay, now let me extend this third law that I just gave you now. This is an extension. It says that when you have um, x, okay, I'm free to use x again now. X raised to the power of a times y raised to the power of b, and then their product is raised to the power of what? C, that you can maintain the multiplication between them, but see what is going to become. X raised to the power of a c times y raised to the power of b c. So did you get that?
Mm-hmm.
And do you agree with me that this is a follow-up to the third law?
Ye- yeah.
Now, did you notice something? Did you see me doing anything like addition anywhere? No. Why? Because the bases here are not the same. The bases here are not the same. One of them is x, the other one is y. So you don't need to add anything, please. Okay? Just
Okay.
remember that this is a fallout of the third law of indices. And I'm sure you pretty much know that if this kind of thing can happen with multiplication, it can also happen with what? Division. When in this case, the bases are not the same. So let's say that you had something like this. X raised to the power of a um, um, divided by y raised to the power of b. And all this is raised to the power of c. Then your final answer, you preserve that division sign, and it will be x raised to the power of what? Sorry. It will be x raised to the power of what? AC. What do you think? Are you following me at all? Do you
Yeah.
understand it?
Yeah.
Okay. X raised to the power of AC divided by y raised to the power of BC. All right. So did you get that?
Yeah.
Does it look like any of the laws that you guys discussed in class?
Yeah.
Excellent. Okay. So don't worry, we're going to do some examples so that you can see these laws in action. Now, the last one which I want to talk about, I should have talked about it before I went to these ones that look a bit complex. X raised to the power of minus a. When you have a negative power, what does it connote? Or what is it going to be equal to? Well, it's quite simple because it will lead you to this. Um, it will lead you to this 1 over x raised to the power of a. Okay, so did you notice something? There's no longer any minus when the x raised to the power of a is in the denominator. Did you notice that?
Yeah.
Okay, so we're ready to apply the laws now. So let's see um, if we can get some questions for indices. I'm sure we would have. I'm sure we should have. Okay. All right. This guy will not let me search. Let's go look. Okay. So indices questions. Nice. Yes. Okay. So this one is talking about the laws. It's not the laws that we need. We need questions. Um, okay. Let me move this here. Okay. I bet you can still see my screen, right?
Mm-hmm.
Okay. So don't look at the top, not really top right, but maybe I should zoom in on it. All right. Can you see the questions clearly now?
Mm-hmm.
Okay. Now I'm sure you might be thinking, but these questions look complex. Well, what I can bet you is this. If you can solve complex ones, the simple ones will not trip you up. Okay. Once you come to the questions with that mindset, then your confidence level will rise. I'm very sure of that because that's how it has also worked for me. So they said we should find the value of 8 raised to the power of 5 over 3. So there's one of the laws I don't think I've said, but let me see if I can quickly mention it before I apply it. And that law says, okay, let's see. Okay, I think somehow have I x raised to the power of 1 over 3. Okay, yes. Okay, somehow I have. But let me just talk about it. So when you write square root, okay, so when you have a root like this,
Mm.
can you see my screen?
Mm-hmm.
Root the eighth root. I'm just using a so that it's general. The eighth root of x. Indices said that it is equal to x raised to the power of 1 over a. Did you guys do this law in school?
Yeah.
Okay, good. So it is this law that I said I want to apply now to solve that question. Let's go back to the question. Let's take a look. 8 raised to the power of 5 over 3. So this one is solving. I'm done with the laws. Solve. We'll solve as many as we can. Okay, so 8 raised to the power of 5 over 3. And they said we should evaluate that. Okay, so look at how I'm going to do it. Oh. Someone else may have a different method, but this is how I'll do it for simplicity. I would first remember that 5 over 3 is the same thing as 5 times 1 over 3, right?
Mm-hmm.
So that means I can write this thing as 8 raised to the power of 1 over 3 times 5. It doesn't look like much has changed, right?
Mm.
Let's keep going. Now, I want to apply one of the laws, and I'm going to show you the law I want to apply. So when you see it being applied, you will see that, oh, really? So laws can also be applied like this. Now, in the human eye tends to only see things in one direction. This is what I'm trying to say. Now, when I showed you this particular law, let me put a square around it. Not that it is anything special, but because that's the one I'm trying to apply now. When I showed you this particular law, I'm sure in your mind you are thinking that it's only when if we see something that looks like the left-hand side, we should write it as if it's the right-hand side. But what I'm trying to explain to you now is that even when you see something that looks like the guy on the right-hand side of the equality sign, you are free by all means to make it look like the left-hand side of the equality sign. Did you get that?
Mm-hmm.
Now, this is that in action. Watch. 8 raised to the power of 1 over 3 times 5 looks like D raised to the power of A times B. Do you agree with that?
Mm-hmm.
So I am free to move it into what it looks like in the left hand side, which will leave me with 8 raised to the power of 1 over 3. Watch this. All raised to the power of 5. Can you see that?
Mm-hmm.
Now I'm pushing it further. Now remember, so maybe I should tell you the laws I'm applying. So this is the one I just applied. Should I give them numbers? Okay, let me give them numbers for clarity. This is uh, law 1, law 2. So when I apply it, I'll tell you the law I'm applying. This is law 3. Now, this is not, it may not be 3 in another textbook. Oh. This one is just my own numbering thing. This is law 4. This law 4 is more like an extension. This one is law 5. And this one is 6. Okay. And this last one is what? 7. Okay, so anytime I apply the law, you can come and reference it here because I'm going to put the number here. So which law did I just apply now? I just applied law, is that 3? Yes, I just applied law 3. So I'm going to put it here that apply apply 3. Okay, so I hope you understand what I'm saying, right?
Mm-hmm.
Okay, good. So I just applied law 3. Now, this inner one, I'm going to apply law 7, okay? Again, in the backwards direction. That's from right to left. So 8 raised to the power of 1 over 3 looks like x raised to the power of 1 over 8. So I am free to do this. Cube root of what? 8. Put a bracket around it and do what? Raise it to power what? 5. Did you see that? I just applied law. I just applied law 7. Did you see that?
Mm-hmm.
Okay, good. So I just applied law 7. Let me write it. So when you are doing a screenshot and going through it again, you would understand the next thing. So now inside the bracket, what's the cube root of 8? Just like square root, something times something will give you something. Cube root is what?
Um, when you divide the number, so
Hmm?
the square root, um, what was I gonna say? So, for
Okay.
example, the
Yes.
square root of 16.
Mm-hmm.
is what's it called? 4.
Yes. Okay.
But then how could I do this? And then you could say that 8 is a cube number as you can do 2 times 2 times 2 to get
Excellent.
8. So
Yes.
the cube root of 8 is 2.
Thank you very much. You've said it all. So the cube root of 8 is 2. Now, remember that there's a 5 waiting for it. So 2 raised to the power of 5. You can now allow the 5 to go inside. And the 5 do, yeah, if you actually know that there's an imaginary 1 there. So by the time the 5 goes inside, it will be what? 2 raised to the power of 5, which
Mm.
we know is what? 32, isn't it?
Mm-hmm.
All right. And that's the final answer. Now, I'm sure you will not in this world ever think that 32, a whole number, will come out of the question. 8 raised to the power of 5 over 3. It will definitely not be one of the things you think can be the answer, right?
Mm.
Okay. So, do you understand the question? Do you understood
Yeah.
the steps? Oh, good. So let's quickly do the second one before the battery runs out on us.
Okay.
Okay. All right. Let me go to the question. The question says, simplify fully. This one, like I told you, don't be afraid of the size of the question. The more complex it is, the more your confidence grows. So when they now give you the simple ones will be like a walk in the park. So here we go. I'm trying to look at the question. Maybe I should I even solve it here. Let me take it up. Yes, let's take it all the way up. Okay, so the question says, looks something like this. 2x something. Let me go and look at it again. 2 times x raised to the power of 1 over 2. Anytime you are given a question, it's always good to rewrite the question. That's a way of like cementing it to your mind while you're working on it. All raised to the power of 3 divided by 4x squared. 4x squared. Here we go. So this kind of question, it calls for careful analysis. Does that now mean you should spend your whole day looking at it? No. But just analyze it the way it comes. I'm sure you can see some things there. I'm going to apply a law because of these brackets. Can you see the brackets here? And you have a power inside and an imaginary power 1 for the 2. A power half for the x, an imaginary power 1 for the 2. This law is fit to be applied. This one, law 4. Can you see, do you remember law 4? The one that says x raised to the power of a times y raised to the power of b, all raised to the power of c. Do you remember that law?
Mm.
Good. So we're about to apply it. I want you to look at the law carefully. Can you see the law so that when I apply it, you not ask questions will not arise in your mind.
Mm.
Okay, so let's go to the law. Let's go and apply it. So the law simply says that 3 is free to go inside and multiply the powers of the guys inside and preserve the multiplication that was between 2 and x. Preserve it. So this is what is going to be. Apply law 4. So like again, I'm saying this, that there's no law 4 in indices. It's just me using it for reference purposes. You understand, right?
Mm-hmm.
Okay, good. Okay, so I'm applying law 4 now. Log 4 will make my work look like this. 2 raised to the power of 3, because 3 multiplied by 1 is 3. And then x raised to the power of what? 3 over 2. Don't worry about the 3 over 2. I'm sure that 3 over 2 will work itself out of the picture somehow and become simpler. Now, the denominator is still there, waiting for us to finish what we are doing with the numerator and come and attend to it. So, this is what it looks like now. I know you are thinking, does it not look more complex? Well, not really. We've just applied one of the laws. The next question we'll ask ourselves is, which law is the next to be applied? Now, 2 raised to the power of 3, like you said back then, is what? 8, right?
Mm.
So things can simplify a bit, because I have 8 on top, and I have um, um, 4 at the bottom. So those guys will take themselves out of the picture to leave me with the x's 3 over 2, and then 4 and x squared. So I'm sure you very soon see the next law I want to apply. 4 in itself is 1. 4 in 8 is what? 2. So I'm left with 2 times x raised to the power of 3 over 2, and all over what? X. Sorry, I do you know I forgot to write the x squared? Please don't forget it. Thank God I looked at the question again.
Mm.
Okay, do you understand it up to this point?
Kind of.
Take a look at it again so that we're not kind of understanding it. Look at it very well.
No, I don't really understand it.
At which point did you get lost?
L- Like the first point, like the two to the power of 3x, 3/2, and then over the
Okay,
4x to the power of 2.
okay. Do you remember the law that says, I want you to go, that's why I asked you to look at that law 4 very well. Please take a look at it. Let me put a red box around it so you know the one I'm talking about.
Mm.
Please take a look at it well. It simply says when two things are
Mm.
multiplying, in this case, the two things are x and y, and the x has a power a, and the y has a power b. And
Mm.
then there's another bigger bracket around those two things that are multiplying. And there's another power c outside, that you are free to allow the c go inside the bracket and multiply the powers of both of them. That's simply the summary of that law. Please look at it and see if you understood what I just said.
Mm. Yeah, yeah, yeah.
Okay. Now, with that in mind, because I don't want to write this law again, it's quite lengthy, and it's not so easy writing with this thing. So let's um, go back to the top and see where we are going to apply it. So look at it. The power outside is 3. It's free to go inside and multiply. I told you that anytime you, just like we said for when we're talking about quadratic equations, in algebra, when you don't see a number in front of a letter, an imaginary one is there. Here too, when you don't see a number on the power of another number or a letter, it is assumed that one is there. Okay, is
Mm.
that okay?
Yeah.
Okay, okay, good. So That's why by the time 3 multiplies 1, you see the 2 now became 2 raised to the power of 3. And then
Mm.
by the time the 3 multiplies, oh, there we go. Battery is almost out. But anyway, I think we'll be able to finish this one. By the time we multiply 3 by half, 3 times the 1 on top is 3 over 2, isn't it?
Mm-hmm.
Uh-huh. So if you notice, I've not done anything to the denominator so far. It's still looking the same, but it's about to change. Okay. So what did I now do next? I evaluated 2 raised to the power of 3, which you told me was 8. And I agreed with you because 2 times 2 times 2 is 8. The 4 cancelled itself and the 4 went in 8 twice, right? Leaving me with 2 times x raised to the power of 3 over 2 all over x squared, right?
Mm.
So the next thing that's going to happen now is that I'm now going to apply, law 2. Now let's look at law 2 quickly before the laptop goes off. Can you see law 2? Let me put another color around it. Let me put purple around it. This is law 2. Law 2 is the law of division. See that?
Mm.
Good. So let's apply it. So I'll just say apply to. Oops. Okay. Apply law 2. Okay. So law 2 says that, of course, we'll keep the 2 waiting. And then we'll now apply, because it's only the x that is involved now. That's going to be 3 over 2 minus what? Minus 2, right?
Mm.
So I know you're thinking, how will we write it? Well, you're free to write 2 over 1. It's fine. It will still work. Now, let's take care of that thing that looks quite funny up there. Now, we know that 2 is bigger than 3 over 2, isn't it? So we'll quickly do something here. You know, whenever you say a small number, something like a small number minus a big number, and you tell us that it is equal to what?
Mm.
The negative of the big number minus that small number, right? Do you agree with me?
Mm.
Okay. So 3 over 2 minus 2 over 1. Let's just do it. I think it will still give us the same answer. If you take, you know how we do, take LCM and say 2 into 1. 1 times 3, 3. Minus 1 into 2. 2 times 2, 4, isn't it?
Mm.
3 minus 4 is what? Minus 1 over 2, right?
Mm.
Uh-huh. So that's going to leave me with what? 2x raised to the power of what? Minus 1 over 2. Next, I'm going to, oops.
Mm.
Okay, Mason, you still there, right?
Yes, Uncle, I'm here.
Okay, good. All right, just give me a minute. Somehow they just restored the light, so let me reconnect. Let's reconnect. Okay, so let me just switch. We're switching now.
Okay.
Okay, I'm back here. Let me share my screen once more. And yes, no, let me do this one. Okay, okay. So can you see my screen?
Yes, sir.
Excellent. So let's progress, or let's proceed rather. Okay, so this was where I stopped, or was interrupted by that break. X 2 times x raised to the power of minus half. You understood it up to this point, right?
Yeah.
Good. So let's proceed from here. Now we're going to, this is the next law I want to apply. This one, the one that says, yes, law 6. In fact, we have almost applied all the laws. Let me just put a box around it so that you can see it. Law 6. And can you see what law 6 says? Law 6
Hmm.
says x raised to the power of minus a is equal to 1 over x raised to the power of a. Just take note that the x and the a went underneath and the minus disappeared on the right hand side. Okay, and then there's a 1 on top. So once you understand what is happening there, let's go and apply it. So this means that if I apply law 6, let me just write it there. So for reference purposes, apply 6. Okay, there we go. Um, it's going to become 2. You can put it in a bracket so that you don't confuse things when you're applying it. That's going to be 1 over x raised to the power of what? Half. Okay. So
Mm-hmm.
can you see how I carefully applied it?
Yeah.
So I've applied law 6. Now, if you want to make it look extra special, you can take the 2 and multiply the 1 on top. So it will become 2 times a 2, sorry, 2 over x raised to the power of 1 over 2. And then, we can now go ahead and apply, which other law are we applying now? We can now apply law 7. And law 7 simply says that when you have a root, okay, and you can even see the direction is still there. The direction is from both from left to right and from right to left. They work. But I'm going to apply from right to left. So look at it from right to left. From right to left, it says x raised to the power of 1 over a is equal to the 8th root of x, right?
Yeah.
So you can guess what I'm going to do now. X raised to the power of half is simply what? The square root of what? X. So that's going to leave me with something like this. The square root of what? X. Now, who would have thought that all that heavy equation, all that long equation that we look at where we started, look at it, looks so clumsy and huge, would come to something as simple as this. Now, I'm sure you are thinking, is this where it ends? No, it goes further because we don't usually leave square roots or in fact roots in the denominator. We don't do that. I don't know if you guys have done surds in class. If you guys have done that topic, that's where you learn about roots. We don't leave roots in denominators. We always try to take them out. How do we do that? By this one is not indices anymore, but it's another topic in maths. But I'll still teach it because it applies here. You multiply the the root by itself. So just take a look at what I'm going to do. Times square root of x times square root of x. Now, anything you do to the denominator for your fraction to balance, you must also do it to the what? The numerator. If not, the fraction is not balanced. Okay, I'm sure you probably have heard that principle somewhere,
Mm.
but it's okay. Now, let me ask
Yeah.
you a question. X raised to the power of half times x raised to the power of half. Did you notice that the bases are the same? So we can add the powers, isn't it?
Mm-hmm.
Half plus half is what? 1, isn't it?
Yeah.
So that means my final answer is 2 times sod x over x.
Mm-hmm.
And that is thy final answer. Okay. I think the question was for you to simplify it.
Mm. Yeah.
Okay. So that's how far we can push that guy. Okay. So let me see. Right. I know that these questions are a bit overboard, but let me look for some simple questions that you will most likely find um in your own test. Let me see. Okay. Um, Let me zoom out. This one's. Let me let me simplify myself. Simple indices questions. You can still see my screen, right?
Yeah.
Hello, Mason.
Yeah.
You can still see my screen.
Yeah.
Okay. Sorry, the thing is trying to open that image. Okay. All right. So here we go. Sorry. Ah, I think. Oh no. Okay. This is my screen still visible like this? This one
Mm-hmm.
doesn't look too clear, right?
Mm-hmm.
Um. No, those guys are looking complex. Huh? No. Okay, yeah. I think these questions are simple enough. All right. Okay, so can you see the ones I want to solve now? I'll solve a few of them, then I'll leave the other questions with you so that you can do some practice on your own. To maybe tomorrow, tonight against tomorrow. Can you do that?
Okay.
All right. So I'm going to select some numbers. I'll start with number one because we have not done any question on multiplication of numbers with the same basis. I'll also do number five. Okay, or let me okay, yeah. Let me do number one, number two, and number one and number two from the first section. Yes, I think I'll start with those ones. Then I'll pick some others as we go along. Okay, so you know what? I know I've not given you time to screenshot. I'll send you this image on WhatsApp. Is that good with you?
Yeah.
Okay. So you have everything in one piece, so you don't need to start screenshotting anything.
Okay.
All righty, so let's move. The first question says 4 raised to the power of 5 times 4 raised to the power of 4. Okay, so this is just us solving things and applying the laws. Okay, 4 raised to the
Oh.
power of 5 times 4 raised to the power of 4. Now, I want to ask you a question. What do you think will happen in this case? The bases are the same, right? So we
Mm-hmm.
can just simply do what? Take one of them, right? And then add the powers, isn't it?
Mm.
Okay. So 5 plus 4 is 9. Now,
Mm.
there are two things. You can either see the answer as this. If they say you should leave your answer in index form, please, there's no need for you to start looking for a calculator to crunch anything. After all, no, everybody knows that you 4 raised to the power of 9 is a huge number. But if they say you should go ahead and solve it completely, like give us an answer, then I don't think it's out of place for you to do 4 times 4 times 4 in 9 places, or use a calculator and do it. In that case, it's going to be a huge number, but I mean, it's doable, right?
Mm.
So maybe we should leave it in index form. If you want to proceed, if they say you should go to the final answer, you know what to do. All right. So because of time, I just want to go to the next one. The next one says 7 raised to the power of 7. At least that's what it looks like to me.
7 to the power of
Divide.
2.
Yes. So let's see. 7 raised to the power of 7. Okay. Divided by 7. Now, what do you think we'll do in this case?
It's plus, it's plus.
Are you sure
Uh,
about that?
yeah, is it plus?
No, it's not plus. This is division.
Wait, no, the question.
Yes, the question is division now. Look at it. This is the one I'm talking about. This one on the
Yeah,
left hand side, number 2.
okay, yeah.
Have you
Oh,
seen it?
it looks like a
It's not a
plus.
plus. Yes, it's not a plus. It's division.
Oh,
Okay. Yeah. So now we know it's division. So what do we do? The law says we should do what? Take one. Please remember, the condition is what? The basis must be the same. And here the
mm,
base is 7. So because they're the same, take one of them and then subtract the powers. But careful, the order of subtraction matters. In this case, is the one on the left minus the one on the right. That's going to be 7 minus what? 2, isn't it?
Mm-hmm.
And that's going to give us what? 5.
7
So
to the
that's going
raised to
to
the
be,
power of 5.
yes, 7 raised to the power of 5. So I hope you are getting how to work these ones, right?
Mm.
Okay. So now let me go and look for some other questions that would interest you. Okay, I'm looking for the ones that have letters now. Okay. Um, let me see. Okay. All right. So let's do that one that says x squared. That's number 5 in the middle section.
Mm.
X raised to the power of 2 divided by x raised to the power of 5. Let's do that one. I'm sure you can equally see how that one is going to play out. X raised to the power of 5. So that's going to be x raised to the power of 2 minus 5, right?
Mm-hmm.
And 2 minus 5 is what?
3. I mean, no, no, no. It'll
Minus
be
2.
minus negative
Yes,
3.
please don't forget. Don't forget, it's x raised to the power of 2 minus 5. Now, always remember that whenever you have division, is the power of the one on the left-hand side minus the power of the one on the right-hand side. It doesn't matter whether the one on the left is bigger than the one on the right. I'm sure you've seen that it doesn't matter. We would still apply, it's a law. A law does not change because maybe one condition changed, and then one condition that was not really a big deal. So it will still be that. Now you might be thinking, should we leave x raised to the power of minus 3 as the answer? Well, some I'm sure some people would leave theirs like that. But then you can now apply that other one, that other law that says x raised to the power of minus 3 is the same thing as 1 over x raised to the power of what? 3. Okay.
Mm.
And then you're good. Okay. Let me look for another question that looks like something we have done. Okay. Um, all right. So let's look at that third section. I know that third section looks like, really, are these guys serious? What are they doing? Okay, now let me take one more from the middle section. Let's see number 8. Yes, number 8 looks like what's really happening there. Number 8 looks like p raised to the power of 5 times q raised to the power of 2 over p raised to the power of 2, isn't it?
Mm.
So p raised to the power of 5 times q, let's see, raised to the power of 2 all over p raised to the power of what? 2. Now, I'm sure you can see clearly here that there's a division sign, and then there are two bases that are the same, one on top and one beneath. Now, if you remember the law of division, apart from saying the power of the one on the left minus the power on the one on the right, it also says the power of the one on top minus the power of the one beneath. Please take note, only if the bases are the same. What that means is that it's only the p's that we're going to be doing this for. So the q will just stay there and wait for you. So it's going to be 5 minus what? 2. So you will not need to write that p at the bottom anymore. Why? Because we have taken care of it. You got that?
Mm.
All right. So the next thing is 5 minus 2 is what? 3. So the final answer is P raised to the power of 3 Q raised to the power of what? 2. That's it. So the Q was just there for fun. Nothing happened to it. It was just there for fun, really. Okay, so let's look at the third section that they look daunting, but in reality they are not. All of them are very easy. Um, Let me see, which one should we do? Okay, let's do number 7. Oh no, let's do number 6. Then maybe we'll do number 7. Yes, we'll do number 6 and number 7. Those ones that are at the bottom. We'll start with number 6. 2x squared y raised to the power of 6 all raised to the power of 2. 2, my 2 looks like a z, but yeah, we all know it's a 2. 2x squared y raised to the power of 6 and then all that raised to the power of 2. Okay, I'm sure you know how to do this one, right?
Mm, mm, I think so.
What will happen to the 2? Can you tell me?
The two will come on the inside.
Mm-hmm. So we are going to start with 2. It will take on the 2 first. 2 raised to the power of 2, right?
Mm-hmm.
X raised to the power of 4, isn't it?
Four. Yeah.
And y raised to the power of what?
Wait, is that 6?
Yes, that's 6.
Oh, and then it goes to a 12.
Thank you very much. And our final answer is 2 raised to the power of 2 is 4. X raised to the power of 4 is x raised to the power of 4. And y raised to the power of 12 is y raised to the power of 12. And that's it. Now let us take on the last one. I think we have tried today. You've seen more than enough exercises to make you be very, very confident on your own when taking on these things. So I promise to do number 7, right? 10a raised to the power of, is that a 5? Okay. If it's not too clear, pardon me, but I think what I'm seeing there is 5. Oh, I see something. Thank you for that reminder. Okay, so there are some things that I will not call them laws. So look at where I'm going to put them. I'll put them underneath here. I'll not call them laws per se. I'll just call them, I don't know what the word is, axioms. They're just there, okay? And nobody even proves them, but they are facts, all right? So what are the axioms I'm talking about? The axiom says, for instance, that any number raised to power 0 is what? 1, okay? Can you see why I said you can't prove it? I mean, who would even think of raising a number to 0? But yeah, it happens in indices. So any number raised to power 0 is 1, and any number raised to power 1 is that same number. Okay. So anytime, that's why I said that they are axioms. You don't question them, you just use them. Okay. Some people try to prove it, but I mean, I feel it's a waste of time. Just know them and use them. So I remember this because I saw something like that in number 7. Number 7 says 10a raised to the power of 5 and then I think that thing that is there looks like b raised to the power of 0 because that's how that's how it looks like to me. But if you saw something else there, please try and solve it with the something else. but it looks like 0 to me. And
Mm.
then at the bottom, I have 2a raised to the power of 3. And finally, what's that? B raised to the power of 2. Okay, so I'm sure you can tell what will happen here. The numbers can take care of themselves. 2 in itself is 1. 2 in 10 is what? 5. Can you see that?
Mm.
So I'm sure that there's a 5 somewhere. Remember, anytime you have the same basis and powers involved, it's as good as taking one of the bases and saying the power of the one on top minus the power of the one down. So in this case, that's 5 minus 3. And then what's the next one? Now, you can do the same thing for B, or you can apply the axiom I just taught you, which means that this one is the one on top there is just 1. And then you're left with B. In fact, don't worry, let's just apply it. 0 minus 2, which is what? Minus 2. So this will be, the final answer will become 5a raised to the power of 2, b raised to the power of minus 2. And some people don't like to see minus in their answers. So you can as well write your own like this. 5a raised to the power of 2 divided by b raised to the power of 2. Okay, any questions? I'm tired, like
No.
tired. Okay,
Hmm.
so I think we can call it a night here. I'll send you this along with that question that we just took some, that image that we just took some questions out from. Please try and do as much as you can. And it will just boost your confidence, as you solve it. If you can share your take a picture of your work and send it on WhatsApp before I go to bed. I'll take a look at it and like maybe give you feedback on it if they are correct. But
Okay.
if not, then yeah, I'm pretty sure that um you can face your tests tomorrow with confidence.
Okay.
Yeah. All right. So let me stop sharing and save this and send you the things on WhatsApp. Okay. So you can have a good night rest and enjoy the rest of your evening.
All right. Thank you, Uncle.
All right. You're welcome.
Bye.
Yeah, bye.